In this video, I want to explore removing from a list, hopefully with less costing. So let's imagine a list. And I keep calling my variable list, but I think that's okay. And I keep making lists of strings, but I think you get the idea. And I made an array list last time. Maybe I'll make a linked list this time. Remember, the linked list class in Java also implements the list interface, just like the array list class, so it behaves exactly like an array list. So I use it in the exact same way. So let's just keep things simple, and we'll add 3 elements, A, B, and C. And then I want to call this method I just wrote, remove, that takes a list and a string. So let's try removing B. Oops, there we go. Call my remove method on list with B, and let's see what happens. Now obviously I could just write list, go remove element B, and that should work. But I want to see what happens when I use my iterator used my method that uses an iterator up here. So let's draw a picture. First, sorry. First we've got list, and list refers to a list that contains 3 elements, A, B, and C. So that looks something like this. A, B, and C got added to my list. And then we call this remove method and we pass B. So that tells me that the value in S is the string B. And then we enter my code. And the first thing my code says is ask list for an iterator and call that it. So that's going to make one of these monster things appear. There we go. Big mouth, crazy eye. There's it. So just add that to my picture. That is it. Okay. Then, we have index, and index starts out being 0, so let's keep track of that too. Index, which is 0. Now what happens? While it has next. Does it have next? Yep. It's got the whole list to go. It's got its whole life ahead of him there. Okay? Now, if it.next equals s, so when we say it.next, this is going to tell us the next value, which at the beginning the next value is, let's see it blurred out, A, and my iterator will advance. It'll hop along to the next position, and it said A, and does A equal S? No, because S is B. A and B are not equal. So we do not enter here, and index increments to becoming 1. So let's make index becomes 1. I apologize for all of the up and down here, but there's a lot to keep track of here, I guess. Alright, so index became 1, and we loop again. Well, it.has next. Does it has next? Yep, because we're here now. So we do have next. So we ask for next, does it.next equal s? So again, my iterator is going to blurt out the next value, which is b, and it's going to hop along to the next position, which is going to be right after b. So we got back the b, and we checked, does b equal s? And I believe s was b. Yes, it is. And so those two strings are equal. So we call list.remove index. List.remove index. Index is 1. So it makes sense, right? Remembering here that this is index 0, 1, and 2, that I would want to remove, if I'm trying to remove b, I should remove the data value at position 1. So all of this sounds really good, except for something you don't know yet, and that's that we are going to crash. And we're going to crash with an error called concurrent modification exception. And actually, the crash doesn't occur just yet. If we're being really technical, and let's be technical since we've worked this far into our example, what happens is B gets destroyed, right? So B gets removed. Since this is an array list, C moves down to fill its place, and this box goes away. Actually, what was it? It was a linked list, but it's a list, so it behaves like this. Doesn't matter if it's an array list or a linked list. Somehow that position gets removed, and I now only have these 2 boxes left in my list. At that moment, having removed it, we get to this line that says, well, it has next. And what happens? That's when we crash, right? So when do we crash? When we use an iterator. So basically when we have the following sequence of events. I think this would be easier. First, we create an iterator. Second, we modify the list or set we're iterating over, and then we use the iterator, right? Those 3, when we use the iterator after modifying it, when the iterator was created before we modified the list, we get one of these concurrent modification exceptions and our program will crash. So we can't do that. That is not a good thing, right? We're going to crash. Which begs the question, what if you do want to remove? What if we wanted to fix this code so that it's successfully removed from the list? And actually, it's a pretty straightforward thing to fix it, because I want to remember that there are 3 methods in the iterator interface: next, has next, and remove. And remove removes the last value that was returned by next. The last value that was returned by next, which is actually often exactly what I want. So if we come back to, oops, sorry, that was on this page. Here we go. If we come back to where we were, then we can fix that code by saying, so we'll start out the same way. We make an iterator, we get that from the list. We loop using has next. I'm not going to need an index in this solution because actually life gets easier when we use the iterator correctly. If the next value equals the value I wanted to remove, s, then all we have to do is say it remove. It remove. And that's it, because the remove method removes whatever we just got back from next. And it does it in such a way that we're not going to crash. The reason we crashed here is because if we modify the list and the iterator isn't aware of how the list was modified, we're going to get back some pretty ugly behavior. So therefore, Java prevents us from using an iterator after a modification, except if we go through the iterator, if we use the iterator to modify the list, if we ask the iterator to remove the element, well then everything's okay, because the iterator understands about the removal and the list understands. That's why I like to picture this monster as literally like erupting from the stomach of the list that we're looping over, right? It's actually emerging from it, because mentally this image helps because that iterator is still attached to whatever I'm looping over, and by being attached, it has access to the internals of that structure so that it actually can remove an element. So if this is an array list, it knows what index it left off at, and it could shift all the elements down and do the right thing. If it's a linked list, then it knows what node it left off at, and it can actually reconnect the nodes in such a way that that element got removed. The iterator is doing the work of removing. And that's a key idea too, because it means when I remove, I'm not just removing from the iterator. Removing from the iterator doesn't make any sense, right? The iterator just hops along some data structure. The remove method for the iterator actually removes from the original data structure. So after calling remove on the iterator, we've changed the structure it was looping over. And that's the way to do it without getting one of these concurrent modification exceptions. Okay, so I think that captures just about everything, all the fun of iterators. I think, yeah, there's just one more thing I want to show you that I think would round up this whole idea. And that's that you don't always need to use an iterator. There's actually a very nice shorthand for using an iterator. So let's go back to a very traditional usage of an iterator. Actually, I want to write it in a certain way so you can see exactly how this emerges. String temp equal, I don't know, s equals it next, print s. Okay, so this is pretty basic, right? We're just looping over a list and printing out each of the elements, and we've seen this code before. There's a beautiful shorthand in Java, or at least a somewhat beautiful shorthand, for writing this code, and it involves using a for loop. So this is sometimes called an enhanced for loop, or some people call it a for each loop, and it looks like this. Since I switched colors there, we'll switch colors here. All right, for each string s in list, print out s. And at first, well, actually, let me give you the pronunciation. So I pronounce it for each string s in list. Okay, so I think it helps to think for each when you see this funny for loop notation here, and to think of the word in when you see the colon, because that's really the purpose of the colon. But this is really shorthand for using an iterator. It really is. This is something we can ask for an iterator, such as a list or set. It turns out it could also be an array. You're allowed to use one of these fancy for loops on an array, but in that case, the behavior is very different, and I don't want to. So what I say about iterators won't apply if it turns out it's an array. But otherwise, if it's a list or a set, what Java does behind the scenes is it asks that list for an iterator. It stores it away in some place temporarily. It asks it if it has a next. It gets the next, and it stores that in S, and then or whatever my variable happens to be called. And then it does whatever with that, like in here I'm just printing S, and then it comes back. So basically, all of this code here is collapsed into this line of code here, this little for loop line, which is nice because, as you've seen, there's a million ways that we can mess up using an iterator, and it's kind of nice that there's a shorthand that keeps us from making mistakes with iterators. Now, this won't work if I want to remove from the middle of a list. Then I need to actually explicitly use the iterator, so I can explicitly call the iterator's remove method. But it's nice to know that I can use this for each notation, which I recommend getting comfortable with whenever I want to loop over a list or a set, and in a way that I might have accomplished with an iterator, that this is a nice little shorthand for doing that. Alright, I hope you feel comfortable with, or more comfortable with iterators. I think you'll find after you use them for a while that it's actually not one of the it's actually one of the more manageable topics in whatever programming you're probably learning now. I think there are a lot trickier things than iterators once you start picturing them as monsters erupting from lists. They're not too bad. Alright, hope this helped.